Okay, good morning, good evening. Thank you for joining us for our kickoff of our quantum and AI event. And we are so excited to have you here. It is a true passion for us to be able to share with you the concepts and exciting science that has come to us in a new waveform. Though quantum science and technology has been available for 100 years, for 100 years probably, at the beginnings, there has been a lot of focus on physics and how to be able to work with the particles. And as I explained recently at a congress, if you think about the atom as a structure and you can understand that electricity is moved by electrons and we move to quantum, we're using the nucleus and different parts of the matter that we are and that we interact with every day, which to me brings me closer to nature and understanding how we can solve the problems of the world that are near and dear to us, the problems that may bring some of the solutions that we may see ourselves, our countries, our families, and friends undergoing. The intent of this event is to hopefully get you excited about thinking of technology in terms of a tool that can help you address some of the things that you might want to change and wonder why no one has done it. It may seem like a big task to think of something around you if you are not an expert in the field that you could change. But the reality is that with generative AI, quantum technology being able to process things quicker and more efficiently, we find ourselves in an era where we can transform the world around us. So know that my intention is to truly empower you with the tools because technology is nothing more than a tool that will help you move your passion and things that drive you forward. So we have a huge community of people that have all volunteered, everyone who is working as an organizer, as an intern, as a mentor, even our partners in the industry, the students, the everyone is a volunteer, and we come together because we really want you to get the best out of this. So ask questions, make sure that you are um, taking advantage of some of the things that we have to offer. And the first thing that we need to do is set you up in Zoom. Si hablas inglés o español, this is what you need to do now. I think we've put it here long enough. So I'm going to admit the last batch of individuals here, and we're going to get started with, okay, one more person. All right. So in order for us to be able to know whether our setup is correct, go to the closed captionings and hit the three dots, and you'll be able to see your speaking language and your caption language. It is important so we can also look at the notes of the event and help you process both auditory, visually, and afterwards as a confirmation of information. Okay. Next thing up, please join our Discord channel. Today is a day where we will be, if someone can repost the Discord channel in the chat, the invitation that I posted before, so it's right at the top, we will be able to get the um, support you in joining. Now, this is important because we are going to be talking about all of our assignments and links to different um, assignments, videos. Last year we did this and we had incredible content created, and we have um, more exciting content for you today. Today, in fact, we have an amazing speaker coming from the industry to tell you about a project in drug discovery, quantum machine learning, and I am so excited for you to meet him. So we will be introducing him soon. At this point, I'm going to give a couple of minutes for you to join the Discord channel, and we will be monitoring for your questions. Now, the point here is that you go and you accept reglas, rules, which is going to be here. I'm going to stop sharing for a second and share this screen instead so you can see what I'm talking about. Okay, give me one moment to make sure I'm not sharing anything that's public. All right, so this is our Zoom. This is our Discord channel. You should be able to see it now. As you can see, I have many Discord channels here. But ours is going to have this Qiskit Fall Fest. When you land, you're going to land on this general area. And what we would like you to do is to please, oh, thank you, Anirban, for sharing that. You're going to land here in general, and you're going to go to reglas, and you're going to hit a click. Do it once. If you do it twice, you may find yourself taking away the authentication that you need. So make sure you come here and then you just click and you should be good to go. Okay. So we have, let me see, do I have to admit anyone else? I do not. Okay, let me go back to this other area. Please understand that our rules are here. And we are very, very serious about them. We want to ensure that this is a safe environment for everyone and that the reasons we come together to support each other are maintained with the utmost professionalism. There are no dumb questions. This is not a topic that is technically usually easily understood. So being a little confused sometimes might mean that you are on the right track. Ask questions. And the places where we are going to be asking questions is usually here in this little live section. So for our next meeting, rather than the Zoom chat, we're going to be asking questions here in the live question section. So hopefully we can transition to have everything on Discord going forward. Now, if you look over here, this is our community, and we have been sharing opportunities for a very long time, different prizes, different internships. We want to make sure that everyone has a chance. ¿Qué pasó?
Disculpen, perdón que interrumpan, pero el link no está funcionando. Cuando vamos a hablar dice que está expirado.
Gracias, y ya te mando uno nuevo. Gracias. Voy un momento. Okay, try it again. Y me dejan saber. Okay, let me get back there. Okay, good. Está funcionando entonces. It's working?
Yes.
Wonderful. Okay, great. So let me go back to where we were. This should have never expired. Let me just change in the presentation. So when I send it out, they don't run into the same problem. Okay.
Hello, ma'am.
Yes, sir.
Ma'am, I was saying, could you please also look into the advertised Zoom link that came via the confirmation message in email?
Okay. I'll have to send that again too. Thank you.
That one I reposted in Discord. So there's the correct one in there if someone's looking for it.
Thank you. Okay. So once we have everyone here, we'll be able to see their permissions. So let me just go in here. Yeah, we have a bunch of people who have landed. So I'm gonna go and update permissions for folks. If you do not accept the rules, then you are not auto assigned a student role. So you must accept the rules for you to be able to see these other channels. Um, hmm. Okay, these are all interns. So please make sure that you accept the rules and you will be auto assigned your student your student role. Okay. And I will be authenticating everyone this afternoon after the call. So you should, if you do run into a problem, you can reply in the chat. Fabian, if you want to go and make sure that some of these people have estudiante. But for example, Satya or Angel Cruz, if you could just confirm with us if you, yep, see, Angel is on it. Angel accepted and he has estudiante and he should be able to see all the other channels. So make sure for everyone else that if you have not accepted the rules, you have to go in here and accept the rules, okay? I'm going to pin this message once again. So, and then to see the pinned messages, you go over here, pinned messages. Okay, and then what is it going to look like? We're going to be sharing with you things like videos. So this is where we're going to put the recordings. We're going to put the assignments, links to our different content so you are familiar with what we are doing. And aquí van a tener, yeah, I'm sorry, I need to stick to English because Danielle is in Spanish. Here we are going to have things in Spanish and in English for those who need it. And then we are going to hear our winners from last year. You could see a bunch of history here. All right. So let's keep going. Let me know, guys, if the chat. Let me see if I can just remove my. If we want to delete. Okay. So I'm going to delete some of these things with the wrong channel invite that doesn't work so people don't get confused. All right, off we go. Okay, so that is unfortunately a lengthy setup, but it's going to be great once we can hit the ground running. Everything we do is going to be open source. For the beginner level, we do not have hardware requirements. You can access Google Colab from your cell phone, from your iPad. You can access all of this very, very openly. We do not need you to buy a new computer. You will be perfectly fine with whatever you have. And what we're going to do, as I just discussed, was communicate going forward through Discord. I'm going to send an email with these instructions for everyone who might not have been able to make it. And so Google Colab is kind of like a place where we can code that is a web-based environment. So You install things, you come back, you do it. You can save it in your Google Drive, so we will be accessing things through your Gmail. GitHub is a software repository. What we do is we have our projects there. So when we share our notebooks where we're going to be accessing things from IBM, then you'll be able to see the information there. You can download it and then put it in your Google Colab and then open it. We'll walk you through what that looks like. Very, 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 very important. You will only ever, and I mean ever, receive emails from EnLuz Strategy or Entangled Cat. We never ask you for any single information unless you have won one of the prizes and we need to get maybe your mailing address for some of the books, or we need to get your project information for some of the computing time that we have available. We have some very generous sponsors that have put together some great things for you to continue research. Multidisciplinary research is very important because it empowers people to bring skills from different fields into our oh, we have a typo here, file condale. So we want to make sure that you can access GitHub. So create a GitHub account if you do not have one. And I'm going to pause here. Do we have any questions? We're going to walk you through these two tools, but I just want to know, do we have any questions?
Nadia, Nirban here.
Yeah.
Can you hear me?
Yes, I can.
On the week one, basically it was more like the tutorials, and we had to go through it. And are you talking about the quiz at the end of the tutorials, which was supposed to be completed because I didn't get time to go through. I had just gone through the tutorials,
Oh, that's
whichever your
okay.
links were.
We're
Yeah.
going to be giving those out on Wednesday, and we're going to walk
Okay.
the team, everyone through them. And so
Okay.
we'll be able to get through that on Wednesday,
Sure.
so we can share with all of the participants what we have for them in terms of the information from Qiskit Fall Fest.
Sure. Thanks.
Just make sure that you ask questions
Sure.
in the Discord channel for the mentors and interns if you have something. I'm sorry, this did not update the last version. So, okay, that's very unfortunate that we have that company have described there. Okay, any other questions? So we have our team. If I could ask Deval and Ali, Sudikin, Johan, Daniel, Lindsay, any of our interns and mentors to turn their cameras on. I would love if it's appropriate for you, or you're available, you can. It just would be wonderful for folks to be able to see you and say and know the hard work that you have put towards being able to bring this into fruition. I am the lead organizer and been developing some of the quantum, I guess, learning path in collaboration with some of our co-organizers. Sudikin, for example, is leading the quantum machine learning track. Deval with myself, and then Deval Verma and I are working on the security track. Ali Enriquez is our Scrum Master. She is working with all of us to keep us on track on GitHub project, and we are very intentional about using GitHub because we would love you to be able to say that you have skills, you have used GitHub, and you know how to do it, and it will be very good for those of you that are in the software world or even the project management world. Daniel Ruiz is our QNOW co-founder in the organizing team, and he is also leading the quantum chemistry drug discovery uh, track. Ali Enriquez is our material scientist who is going to be presenting about that. And then Lindsay Bayak is our data scientist on the team, and she is also been working on other marketing things. So we are going to be probably hearing some more from her later during the event on some applications in the classical side. Johan Carvajal is a professor and PhD from Delft in aerospace engineering. He is professor in El Tecnológico de Costa Rica, where whom we are partnering with to host this event. It is super important for us to have content in English and Spanish because it is very few and far between. So just know that there's a lot of people working to do the same event double. And so to our interns and mentors, let's see, we have Fabian and William and Esteban, and a lot of Anirban is also one of our interns. We have Ali Moral. Let me see if I can get this in a big. I just want you to, give him a big thanks, and to those who have applied to we had extremely high profile applications this time. There's Ali, there's Maral, and Lindsay and Sudikin. Okay. So I just want those to know who applied that we are having other things, and so we are going to send you some opportunities that you can still engage in later in the event. So interns and mentors are also able to win some of the prizes that we have for this event. And so I just want you to know that it takes a lot of courage to give yourself the opportunity to succeed in something new. And congratulate yourself for giving it a try. We're here to support you. So we have here, what are we going to do? All right, Nydia, get to it. What are we doing? We're going to be adding to this a little bit more because I have some things we're confirming. But for this week, we're going to be talking about tools today, our basis from data to AI ML. We're going to watch a recording in a second. We have Quantum and Qiskit 101 seminar that's going to be presented by IBM on Wednesday. And we have our Quantum and QSR drug discovery presentation coming in soon. And then quantum machine learning that is going to be presented also by my partner Sudikin. And then on the second week, we can see more from quantum machine learning, quantum security, quantum teleportation, and drug discovery. And so we're going to continue filling in these things. What we want to do, is ensure that we don't give you too much too fast. The certifications that we're going to be able to achieve are going to come here in the second and third week. And then in the fourth week, we are going to have our hackathons, our quantum ecosystem
Media.
opportunities. Yes.
Are you sharing
Media.
the presentation? It's because we're seeing this. Are you sharing like the
Yes,
presentation?
I am
It's
sharing
because
the
we're seeing
presentation
Discord,
this whole time.
I think.
My goodness. Okay. Thank you. That's not great. Okay. All right. So let me just go up here. These are the faces I was talking about. And this is our schedule for very high level schedule for the following weeks. We're going to be filling in additional things in week 2 and week 3. So week 1, we're big, from zero to hero, like it was in the invitation. We're going to be helping you understand what even is quantum machine learning, classical drug discovery, etc. And then on week 2, a little bit more of this in quantum chemistry. And then we are going to support you also to get the badges from IBM if you wish to do that. And we will be giving you the opportunity to get certifications. And what I mean by opportunity is that there is going to be some knowledge validation that is going to take place. It's just a quiz to understand if you get the critical thinking aspects everything with generative AI. I'm not going to ask you to do something super complex because we encourage you to use generative AI. It's not like don't get a calculator and don't cheat. It's use it and use it well and learn how to make it do things for you that would accelerate data discovery, data scrubbing, encodings. Have your strategy, and we're going to walk you through how we can use it to make things quicker for you. Okay, I'm very quickly running out of some air to talk, so we're going to get together, we're going to talk, we're going to get to know each other. Our quantum community, Entangled Kent, has been founded with the purpose to support each other in our professions, to get together and do multidisciplinary research, and to be able to also know how to apply for things, who is looking for people, where are the opportunities. Some of the folks here have applied for some opportunities that we have shared. We have a very vast network. Get to know people. We're going to have a happy hour this week in English. I'm going to put a poll on Discord to see what days work better for all the attendees. And then we're going to have a cafecito in Spanish. Also going to ask you what works for you. We'll give you some options that work for us, and then whatever works for the majority, that's what we're going to go with. Very proud to say that we're going to have the first ever, and when I say ever, I mean ever, Semana Cuántica, Quantum Week in Costa Rica, and we have some very strong universities. We are inviting everyone. It is open to everyone, and so we will be sharing those links for you to sign up. I'm very proud to say that Q Now is hosting and leading in Buenos Aires, Argentina, in the IBM Tower, a networking event that I think they called Positive Disruption. I can't remember exactly the words right now, but have some incredible speakers. And if you are in Argentina, please sign up, go look at those beautiful IBM offices and get a chance to really meet some of these brilliant people in person. And we have one more event in IIT Ropar, which we will be announcing within the next day or so by Wednesday. The IIT Ropars event and the Triangle event in Durham, North Carolina, which I am leading, we're working with logistics to get better places and times that work for people. So just stay tuned so you can come and mingle with all your fellow quantum enthusiasts. So, been doing a lot of talking. Who has questions? And I'm going to pause here. If you have questions, get off mute and you can ask, or you can ask in the chat. I know that our team is working on the chat. No? Okay. All right, so we're gonna.
Excuse me, could you say like about the hackathons and like the what are the prizes afterwards?
Sure, we're gonna be sharing that on Wednesday on which specific hackathons we're gonna have by each track. And so there's going to be quantum machine learning, security, and life sciences. And we're also going to have humanitarian challenge. So we're going to be sharing that in more detail. What we're doing is trying to give you all the boring announcements in between all the cool stuff, so we don't get you too so we don't have to talk too much on the same thing. So on Wednesday, we're going to be announcing what it is, when it's going to start, and what you can win. We have thousands of dollars of computing time and several books. We have grants for education and travel. So if you are doing research and you want to apply for a paper and you're doing something and you win this award, then we are happy to support you in getting there, which is super important. And we also have a prize for supported research. So we would be your mentors on moving your research forward, and we would have to work through what the research is, a period of time. So we would be giving mentoring and hours to be able to bring that forward and potentially to a paper if that is what people are looking for. But that's a good question, Marl. Thank you for asking. So we'll give you all the details so you can, keep them, you start thinking which track you want on Wednesday. Okay. Any other questions? Okay, so you can also work towards some IBM badges. So Qiskit Fall Fest is one of those events where IBM Quantum works with us and they say, here are some things that we think that you can go over. They give us some notebooks, some hackathon prompts. We take that and make a lot of work for ourselves. And how we do that is we translate it. We give you we give you the chance to earn certificates through us also if this is if this is too much. Some of these excuse me, some of these classes are very focused on the there's a lot of math, there's a lot of quantum mechanics. Not everyone here is a physicist, and since we are focused more on the applications and algorithm development, quantum computing has quantum error correction, algorithm development. We have and people in photonics, we have people that are working on hardware, different types of hardware. It is so much. We're trying to remove the stigma of nothing is happening with quantum. That's not accurate enough. To actually hear all the current applications. They're publishing papers. They're moving science forward and getting people excited to do that on their own. And with that, I'm going to stop sharing. We are going to be sending some of these links again, and then I'm going to play something for you. Organizers, chat monitors, is there anything that we need to address before we play our recording, our first presenter? Okay, I'm taking silence. I don't know.
Yeah, you can go ahead. We'll take
Okay,
it.
so I'm gonna ask Deval, could you do the honors of presenting our dear Sudikin? And let me just put this over here so you can do that.
Yeah, hi everyone. Hi everyone, I'm Zaval Robo, one of the co-organizer of this event, and I am here presenting you for the king from IIT Roper, and he will tell you about quantum machine learning and also a video regarding that.
Okay, so let me put this in a preview so you can see it. Excuse me. Okay. So here you go. You can present him, and I will queue up our.
That's for the game.
Hold on a second. I don't know why it's not working.
Okay.
That's supposed to run through a video explaining this. Sorry for the technical issues, folks. We will be with you shortly. All right. There we go. Okay.
Yeah.
All right. Go ahead.
Yeah, so
Okay.
we can. No.
Yeah, go ahead. You can read his bio and present him. Thank you, Deval.
Oh, sorry. Yeah, sorry, Nadia. Yeah, hi. So here is Sudikin. He hold a master degree in physics where he focused on solar flare perturbation. driven by his passion for teaching. He went on to earn bachelor degree in education and has 11 years of experience in teaching physics, mentoring several All India rankers. He also pursued an MTech in geoinformatics at the Indian Space Research Organization (ISRO) as a Golden Jubilee Scholar. Additionally, he holds an All India rank of 30 in the GATE examination. During his MTech, he is assessing quantum computing algorithm on Earth observation data. He possesses deep knowledge in quantum physics and geographic information system. Sudikin, can you please turn on your camera and present the video? Thanks.
Okay. So Sudikin, I will, if you just share, I'm going to queue up the video. If we have issues with what you're presenting, then I will present it. Okay. Are you able to hold on, Sudikin? You're on mute. Skew mute. There you go.
Can you
Yeah.
unmute yourself, Sudikin? Thanks.
Am I audible right now?
You are now, yes.
Yes,
Yeah,
go.
hello everyone. So I hope you would learn a lot from that video. And ma'am, I would love if you could present that. I'm having some technical issues here. Thank
Sure,
you.
no
Thank
problem.
Yeah.
Yeah, our bandwidth is a little off here too, so I am just pulling the video here. Did you send me the you send me the link? Sudikin?
Yes, ma'am.
I have it. Hold on one second.
Hello.
Okay. And I will just say that a very hearty congratulations to Sudikin for coordinating everything with IIT Ropar. He has been our point of contact, our incredible partner, and the amount of work and pioneering that requires to bring different things to our groups is very, very important. So this is part of why we do what we're doing, and we hope that you enjoy his outstanding creation from last year where he was an intern with us, and this year he is coursing his PhD in quantum machine learning. Here we go. Let's take it away.
Hello. How are you? I hope all of you are doing fine. I am Sudikin Pramanik from EnLuz. I come from India. I have a master's in physics, bachelor's in education, MTech in geoinformatics from Indian Space Research Organization. Here, I use quantum computing for feature extraction on Earth observation data. I've been a teacher for over a decade. I teach physics, mostly high school and undergraduate physics. I love to stay among students. I'll be your guide and friend for today. I'll be helping you out in understanding a very complex topic, which is translating the world around us to data and strategies to algorithms. It's a technical exploration. I thank EnLuz for giving me this opportunity to help you guys out. Without wasting much time, we'll directly delve into the topic. So our topic is divided into 4 parts. We'll go in each part with a detail, but keeping in mind that as most of you may not be from this background, you may be having problem in understanding them directly. So I'll be using some analogies so that you can understand it in a proper way, yet I'll be delving into some deeper topics also. Okay, so first is how data is as a representation of the world. So how we see data in our surrounding. So in this thing, we'll learn data acquisition, data pre-processing, and data representation. So let us understand data acquisition. So how about we make some food? All of you love to make food? Chalo, let's make some food. How about a simple potato dish? But first thing for a potato dish is what? We need a potato, right? So we need a potato. So from where do we get potato? Farms. Similarly, to do anything with data, first thing is we need data. So where do we get data? So how can we collect real world data? Think of a sensory device that you have since birth which can collect data. Think. Right. You have your eyes which can see, your nose that can smell, your skin that can feel, and your ear that can listen. We all know this, right? So what type of data are they? Okay, to understand that, we have to discuss more on it. Let's take for an example our eye. So what do we have? Light enters through the lens and falls on the retina. Then what does the retina do? The retina has photosensitive cells. What are photosensitive cells? Cells that responds to the amount of light falling on it. Okay, because it is sensitive to light, those cells are known as rods and cones. Now these photoreceptors convert the light energy to electrical energy. Then what happens? Then these electrical energy are actually electrical signals, which we may as of now call as analog electrical data. They are transferred to brain. The brain stores them in neurons as synaptic strength. So what did we understand? Light enters from the lens, falls on the retina. Okay, this is the black spot. It falls on the retina somewhere. Suppose it falls here. Now here it is converted to electrical signals. These electrical signals pass to the brain and it is stored somewhere in the brain. Okay. Now let us understand what happens in a satellite, because I'm mostly working on satellite data. So let me explain you what happens in a satellite. So light falls from the sun on an object, it gets reflected. Now the satellite catches this light. Then what happens? So light falls on a satellite sensor. What is a sensor? Anything that receives the data is a sensor. Anything that can understand the data is a sensor. Okay, suppose our light is falling on it, something is able to understand what is falling on it. That something is the sensor. So it is then converted to analog signals at the sensor output. So suppose this is a sensor, light falls on the sensor, sensor gives you a output. Okay, now the output falls on an analog to digital converter. It converts the analog signals to 1 and 0. All of you know, then it goes through a analog to digital converter. Then we get only 0 and 1 and nothing else. So we get an analog signal that falls on a sensor, passes through a circuit, gets only 0 and 1 in the output. Then it is transferred to a memory device where the presence or absence of electrons ensures the stored value as a binary memory. So then what happens? There are various ways of storing our data. So one can be by the absence or presence of an electron, meaning a 0 or 1, then can be stored. All of you know this thing na, that flash drive, hard drive, memory drive, like these are the various storing devices. Okay, so data can be stored there. Okay, now what are the various types of data? There can be geospatial data, financial data, temporal data, multimedia data, biometric. What is geospatial? It has geography, that is geographical and spatial data. What is financial data? That relates to money. What is temporal data? Relates to time. Temporal data relates to time. What is multimedia data? Your audio video data, the videos that you see, the music that you hear, they are multimedia data. What is biometric data? Data relating to human bodies or any body parts. That is biometric data. Now you have got the data. So suppose you went to a field, you picked up some potatoes from the field. So how is the potato? The potato has the potato bulb, then it has the leaves with it, right? Now suppose you want to make a dish of potato. Can you put this whole potato and eat it? You cannot now. So now we have collected data, that's fine, but can we use the data as we have collected? It is like you have picked up a potato from a field, but can you eat it directly? No, right? So you need to wash it, peel it, remove any unwanted portions. This is what is similar to data pre-processing. So what you did is that you took the potato from the field, you processed the data. Okay, you processed the data before actually using it. That is the pre-processing. So data pre-processing is a series of operations to ensure that raw data, what is the raw data? The initial data that the satellite has taken, to become usable for algorithmic modeling. So we want to do some process on the data, right? Now in pre-processing, we'll use that end part of the satellite data, then we'll do some cleaning and stuff on it, then we'll get a processed data, right? So what are the various things? That can be data cleaning, that is handling missing data, removing some noise, doing normalization, standardization. There can be data transformation where we do encoding of a categorical data. There can be range compression. There can be feature selection and dimensionality reduction. What dimensionality reduction? See, suppose I have a satellite data which is having 250 bands. Now to process the 250 bands is very difficult for a normal computer. So we need to reduce the number of bands. Yet we need to understand that when we are reducing the number of bands, it should be such that we don't lose a major part of the data. So we do feature selection and dimensionality reduction. Then we do data augmentation. Then we do data integration. These are the various processes in which pre-processing can be done. Now we have taken the potato from the field. We have cleaned the potato. Now what is the next step? Shall we directly put into the oven? No, na. Suppose I have a bag of potato. What do? We store them. So that is the data representation. So now we have cleaned the potato. How do we keep it for future use? Yes, we can store it as a whole in a shelf, or we can store it in bulk in a large sack. So which is better? Storing in a shelf is better, or storing in a large sack is better? So what happens is that we can separate different sizes and sort them accordingly. Suppose I have various kinds of data, I can sort the data and I can keep it accordingly. Or shall I put everything in a sack and I keep it? If I keep it in a sack, putting everything together, will it be easier for me to find out a specific kind of potato if I need it? Suppose I am making a dish, I need small potatoes. I am making another dish, I need big potatoes. If I keep it in a sack, it will be very difficult for me, right? So we would like to keep it in arranged orders. Similarly, we need data to be structured, formatted and organized so that in future it becomes easier to process using algorithms and models. So we also need to keep the data in such a way, arranged in such a way, so that when we need the data in future, we can take the data directly without much hassle. Okay. So we understood what we do when we find the data, process the data, pre-process the data, and we keep a representation of the data. Now, there are some methods of representation. They can be tabular data, sparse representation, graph representation, time series representation, image representation, and vector representation. Okay. Now let us move into part 2. So we have got the data, we have cleaned the data, we have kept the data aside. Now we are looking at strategies as computational models. So what are they? First is algorithmic design, machine learning, then hybrid model. So let us go into algorithmic design. So what is an algorithm? So now we have our potato. We need to process them so that we can get a desired food or a craft. Let's talk about food. Now how can I transform the potatoes in a product? Shall we go with any unknown technique or shall we experiment with the unknown? So shall we go with a known technique or shall we experiment with the unknown? I need to make mashed potato. So what do? First we hear from our elders or from a recipe, how have that been made earlier, so that we can get an idea, or we need to follow the steps. So to do this, we need to determine the various methods. Similarly, for data, these methods can be deterministic or stochastic. Okay, so now we'll understand what is stochastic data, what is deterministic data. First, understand deterministic data. Deterministic data follows a strict recipe. Suppose you want to make mashed potato, someone has written a recipe, you do everything what is stated in the recipe, you follow every steps. Okay. What is a stochastic method? It's like adding a bit more of clarified butter to see if the recipe tastes better. Like you want to make mashed potato, you are not following a recipe, you are trying with the recipes. You are putting sometimes more amount of butter, sometimes more amount of chili, sometimes no chili. So what you are doing is you are not following a recipe. You are randomly doing things, yet you are doing things in a way that will be meaningful. Okay, so as an use case for deterministic method, using predefined algorithms like sorting and modeling. So for data, we can have predefined algorithms which are already said, trusted, proven, and then we can put our data and find out something. So they can be like binary sort, quick sort. Okay, now for stochastic method, we can incorporate randomness in the decision making process. Like we can do optimization problems like genetic algorithms, simulated annealing, or stochastic algorithms like Markov chain and Monte Carlo simulations. Okay, now our second portion is machine learning. Now I think most of you have heard this thing about machine learning, right? It's a very buzzword right now. So suppose you have Parthiv as a customer who wants mashed potato with a lot of chili, and you have Niloy as a customer who wants mashed potato with very less amount of chili. Now it is not mentioned anywhere in the recipe what to do for such customers. You have a recipe, but you don't know what to do when a customer suddenly asks and tells you a new thing. I want more chili, or someone will say, no, I want very less chili. What will the chef do then? So what the chef does is he learns from the feedback. So first he will give Niloy 1 spoon of chili in his mashed potato. So Niloy eats the mashed potato and says it is too hot. So what will the chef do? Will he increase the amount of chili because Niloy does not like chili? So what the chef will do is he will decrease the amount of chili. So what should the chef do? The chef will decrease the amount of chili. Yes. So he will decrease say to half spoon. This is how the chef is learning each time from the feedback of the customer and providing forward food with new adjustments. See, he's very happy, right? So now I hope you think of what to do with Parthiv. Now Parthiv likes more chili. What to do? Yeah, he'll again put the half amount of chili. Parthiv will say, no, this is not at all hot. I need more chili. So what he'll do? He'll put more amount of chili and more amount of chili, and every time he'll take the feedback of Parthiv unless he is satisfied. So similarly, for data based on machine learning, we can learn pattern and relationships from large data sets. Okay, there are patterns in data. Machine learning learns those patterns in data by giving forward and backward inputs and output. Okay, so there can be popular machine learning techniques like supervised learning, example SVM, unsupervised learning like discovering pattern from unlabeled data, reinforcement learning, that is learning through interactions with environment and optimizing strategies. Now let us look at this picture by our side. See, can you tell me what will this dark blue portion represent, or this yellow portion represent? See, all the dark blue portion are classified as water. It is done by machine learning technique. All the yellow portions are cropland. So machine learning is very capable in figuring out information from the data. Now let us talk about hybrid model. So what is hybrid model? Now suppose the chef knows that Niloy eats less chili in mashed potato. We remember Niloy? Just we talked about Niloy. So Niloy does not like chili. So he eats very bland food. Now he wants potato chips. The chef does not have a potato chips recipe with a less chili. So what will the chef do? Chef will have a recipe of potato chips. Chef will have an understanding of Niloy. So he'll combine both of the knowledges and will produce a hybrid approach. So what does it mean for data? It means that many systems leverage a combination of deterministic algorithms and machine learning models. For example, in a recommendation system, content-based filtering algorithm may be used in combination with collaborative filtering model to recommend products based on user preferences and behavior patterns. Okay. Now, so what did we do? Let us do a brief review. We got data, we processed data, we kept the data. Then we took the data, we used some algorithms, and we used some machine learning models to find out some information from the data. Now, how about the complexity of getting those results? So what is complexity? Complexity means, suppose for time, how long duration it is taking. Suppose for space, how much memory space it is taking. Parallelism, how fast it is happening, or how many parallel things can you do together with the data. So let us talk about time complexity. So now let's talk about a business firm who wants a mass produced chips. Now suppose to complete one batch of, he needs a time of 6 hours. So he can produce a maximum of 4 batches in a day, because 6 hours 24 by 6 that will be 4, right? So he can produce a maximum of 4 batches of chips. So how about he has developed a process in which he can complete one batch in 2 hours? That means 24 divided by 2, that will give 12, right? So if he can somehow reduce the process in lesser amount of time, he can do more work within his time limitation, right? That is how beautiful is time complexity. So in case of data, what does time complexity mean? It means that the computational cost of an algorithm is typically expressed in terms of time complexity, often denoted by big O notation. The time complexity quantifies how the running time of an algorithm grows with size of the input. See, you see this red thing, and it is steeper, right? That means how steep your curve is, it is more complex, and how flattened your curve is, it is least complex. So there are various types of complexity algorithms which can reduce the complexity time based on an operation. Now what is space complexity? Now a new batch of potato chips has come out. So shall I store it in sacks on the floor? I have made a finished product. I have made a bag of potato chips. So how do I store it? Just imagine how much floor area will it take to store it in sacks. So I am storing in sacks. I don't have racks, I don't have anything. I'm just storing it in sacks randomly. Is it a good idea? Don't you think it is more economical to have less space for storage? Right? So I have lots of sacks. I have not organized that. I don't have any racks. All sacks are lying on the floor. I have thousands and thousands of sacks. Is it a very good idea to keep the sacks in that way? No, no. That is space complexity. So what does it do? Space complexity refers to the amount of memory required by an algorithm relative to its input size. Optimizing space complexity is crucial in environments with limited computational resources such as embedded systems and mobile devices. In mobile device, how much data can you get? 256 GB maximum. Usually you get around 128 GB. So if the space is not optimized, what will happen is that it will use up a lot of space, and that won't be in a good spot for you, because you will keep on buying new memory cards or new phones or deleting data. That's not a good thing. So we need space optimizations. Now what is parallelism? So understand in this way that suppose a batch of potato needs 50 minutes to bake. One batch requires 50 minutes. Now however larger machine or better machine you take, you cannot reduce the frying time. That is fixed for a potato. You can, for packaging, for processing, you can do a lot of time. You can reduce the time, you can do things, but for frying of the chips, 50 minutes is required. You cannot reduce that. Now it will ensure that the chips won't be fried properly if you reduce the frying time. So what shall the businessman do? So he can modify his instrument, but he cannot reduce the time. So what he'll do is that he'll set up many small manufacturing unit in place of one large unit, so that he can fry more chips parallelly in a small batch, ultimately gaining a large volume. So what he'll do, he'll not make a very big machine. He'll make small machines. All of the machines will take 1 hour, 1 hour, 1 hour, 1 hour for the potato to fry, and he'll make many batches of potato. At the end, he'll collect all the potatoes and make a small and make a large volume from these individual small volumes. In that way, see how many number of batches he's making, how fast it is happening in terms of volume, though he's giving small batches in small parts. This is parallelism. So what is parallelism? We usually take a task, do one after the other, and get the solution. What he is doing is that he is breaking the task into small portions. Then they are processing the same step, and then ultimately the entire collection of the result is his final collection. So MapReduce, for instance, is a distributed algorithmic framework used in big data environments to process large data sets. Similarly, GPU-based computing is often employed in deep learning to accelerate matrix operations via parallel execution. I hope you have heard about NVIDIA. What is NVIDIA? NVIDIA is using GPU computation. That is, he is distributing the task parallelly and getting the result much faster. So now so let us recapture what we have done. We have taken the potatoes, we have cleaned the potatoes, we have organized the potatoes. Now we made a recipe with the potatoes, we made a batch out of those recipes, and we have stored the batch. We have also seen how to reduce the time, how to reduce the space and optimization things, and we have also learned how to make the process faster. This is what we have done till now. Now we have our batch of potatoes ready. Then what to do? Will you keep the potatoes with yourself, or will you try to sell the chips? Will you try to sell the finished products? This is what is translating outputs back to the real world. So we take things from the world, we do something, we give it back to the world. So first is visualization. Suppose in your industry you make two varieties of chips. One is classic salted, one is onion flavored. Now you have packed them. Suppose you pack them in this way, which has no labels, nothing, just a transparent bag. Do you think it will be easy for your customer to understand which variety of chips it is? Will it be easy? Will he be able to understand? No, no. So your sales, will it go up? No, no. So you need to represent your results in such a way that it becomes easier to understand for your target buyers. So suppose you have a onion flavored chips and you have a classic flavored chips, and you have different packaging, so the customer will easily understand and pick up his desired results, right? So in similar way, output of a data is usually numbers. So how will the spectator understand gigabytes of numbers? Like so many numbers, you cannot understand directly from numbers. So data visualization techniques such as heat map, scatter plot, 3D graph help in summarizing and interpreting complex data structures and model outputs. So see, this is the map of USA. It shows that where the price of electricity is high is marked in a deep dark color. So see, this region is having higher electricity price, this region is having lower electricity price. Okay, now actuation. What is actuation? So you have a nicely packed product. So what do you do now? You sell them, right? So you distribute and sell your product. You want to deliver the product to the actual customers. That is, you want to see the implementation of your product. So you give them to a grocery store, restaurant, online store, so that your product can be utilized to the ultimate goal of making. So you are making a chips, you want to sell the chips. So you give them to the grocery stores, to those places. Similarly, you made a result, you made a pre-processing, you made a data. Now you need to see the result of the data. Suppose you are working on robots. So what you will do, you will feed the data into the robot so that the robot does some work and you can get the result from viewing what the robot is doing. So this involves implementing changes, triggering events, or initiating processes based on the analysis of data. In systems involving physical components such as robotics or industrial automation, the final step may involve actuating physical devices based on algorithmic outputs. In such cases, control algorithms translate high-level strategies goals into real-time actions for motors, sensors, and other hardware components. So we understood what is actuation. So the robots will behave, we'll understand from the movement of robots that what we desire to do, have we been able to do that in the way we wanted it to do? Next is decision support system. Now this is very important. Decision support system is very important. So what is it? So your chips are sold, the stores are placing orders for more amount of onion chips than classic chips. So what do you understand? So you understand that your demand for classic chips is less than the onion chips. So tell me, in your production line, which chips shall you produce more? Onion chips. Obviously, because people are liking it more. Or after some times you find that, let us go to the chef example. You find that Niloy, who used to eat very less amount of chili, now is asking for more chili. So what do? Shall you still give him less amount of chili in mashed potato? No, no. You will increase the amount of chili. So you need to take decisions. That means you need to have a decision support system that will analyze and produce decisions based on your informed analysis. In a similar way, in decision support system, for real world data translated into the machine data, decision support system incorporates model management systems that simulate the real world systems to enhance understanding and identify improvement opportunities. So what to do with the data? What the decision management systems tells us that which things to look into, which decisions to take, which are the correct ways of handling things. So organizations utilize these models to predict how outcomes will shift with various adjustments, particularly for complex, costly or hazardous systems. So they cannot be fully explored in reality. We have various techniques of MCDM. What is MCDM? Multi-criteria decision making. We have algorithms like HP Topsys which help in fulfilling the decision requirements. So in conclusion, the journey of the potato from farming to the finished product, I hope it explains in a very easy way, parallels the process of translating real world data into data and algorithms. So I hope the analogy I used was able to make you understand the topic in a much easier way. So each step from cultivation and harvesting to processing and distribution reflects the complexities and strategies involved in creating actionable insights from raw data. So ultimately leading to a product that meets customer needs and preferences. So I hope you understood what I have tried to tell you. Thank you. I have been very happy being able to help you all. Looking forward for more events to come. Stay connected. Bye bye.
If no one ever taught you how to manage your money,
Hello all of you. So we just went through the video. So if any one of you is having any questions, you could ask me. Today is the first week, first day. So it is a very introductory part where we will introduce you to the new things and so that you could get accustomed to what we are going to do the more deeper level things in the coming weeks. So yeah, if you have any question, any queries, or if you would love to just interact, I would love to do that. Yeah, I've tried as simple as I could do for an introductory part to continue. Yeah,
Nicely done,
so
Sudikin.
Any
yeah,
recording can be
ma'am,
given.
you can, yeah,
Session recording will be given to us.
Yes,
Okay. So
yeah,
it will be
absolutely.
uploaded on Discord.
yes.
Okay, okay, thank you.
So,
Okay, so anyone else?
this is Anirban. So,
Yeah,
I have a question. So, whatever he covered, it is most on treating the potato as a particle, right? Not as a wave. When we talk about wave particle, so are we throwing any light on this duality and uh, things like when we cannot determine the momentum or the position at one point of time? So are we going to have any discussion on that? I have actually gone through a lot of videos, but just wanted to know that are you going to take to set our mind for the quantum stuff? Yeah.
Absolutely. So, Sudikin, I'm going to take that
yes,
as
ma'am.
a beginner-friendly course, and as someone who has been in the industry working with a lot of people who are have a lot of experience in different things. I've noticed that one of the main critical failure points is that these do not have strong bases, meaning what? They don't do data processing properly. They don't understand some of the time complexities and the different complexities, and this is the basis. So we will definitely cover the quantum terms and different things on when we get started on Wednesday. And so this is we are giving our IBM partners the first chance to introducing it in their way. And then after that, we are going to introduce it in our way with analogies and a different way of seeing quantum and the uncertainty principles and all of that. As stated at the beginning of our presentation, we are not going to go very deeply on the quantum mechanics as such. We are going to describe the phenomenon, but it is very important for encodings and quantum machine learning and all of the growth that we have in our in our systems to be able um, to understand the basis properly. I tell you, I this is how this is how we actually get hired a lot because we're trying to do something very advanced and some of the bases are wrong. So it seems that there are some questions here for you, Sudikin. So what I'm going to ask is that we answer them in I'm gonna ask Alejandro to go off mute and turn off his camera. I'm sorry, turn on his camera so he can get ready. Hi Alejandro. Okay, can we hear? Okay, while I set up to introduce Alejandro, the question for you, Sudikin, was if you can explain what kind of complexity. I'm not sure which complexity, and the person's name is not very clear. But if they answer quickly, then you can answer their question, and if not, I'm going to set up Alejandro. Alejandro, if you wanna, I'm gonna make sure that you can. So if the person who asked the question wants to, kind of confirm which time of complexity you would like him to go over, then we are happy to do so. Otherwise, we're going to get started with our next speaker.
Yeah, ma'am. He said space complexity.
Okay, do you want to proceed?
Yeah, so that's fine. So
Mhm.
see, as we know that we are limited of space. So now, suppose you are working with a huge amount of data in a single image. Suppose you consider a high resolution image with a lot number of details into it. So that will cover a lot of memory. So how can you utilize the minimum number of space for the same number of given image? So I would like to go and tell you about this would be discussed later on. Maybe today is the very introductory part, but I would like to say you could go into some algorithms like FRQI, NEQR. So these are image representation algorithms. So what they do is so in an image, suppose you have around 16 by 16 image, so it acknowledges to 256 qubits, 256 bit spaces or registers in your semiconductor device. If we go in the quantum domain, so that can easily be represented by 4 into 4, 4 plus 4, that is 8 plus 2. That is only 4 plus 4 plus 2, that accounts to 10 qubits for the size of equivalent to 256 bit. So that's a huge reduction in the space, and that could reduce the space complexity as well. So yeah, here is my answer for that. Thank you.
Wonderful answer, and exactly that. When we go over some of the other terms, you'll understand space complexity a little bit more. It has to do with, as he's saying, fitting into hardware. Excuse me. Bad data gets sick, folks. All right. So,
I uh, Nadia, I have one more
well,
question.
hold on
Can
1 second. So,
I ask?
if you want to ask it, you can ask it either here on the chat or on our Discord channel, so we can answer you. I just want to make sure that we respect our next speaker's time and get started right away. Sorry,
Sure, sure, sure,
but I just
sure,
want to make sure that we are on time for that. And so let me introduce him over here.
sure.
And thank you. Okay, so let's take all additional questions. Sudikin loves to answer, and he is a depth of knowledge, and we will be exploring these as classical and quantum further. We just did not want to go head forward and with the head first with the very complex topics. We want to make sure that we can anchor on our current knowledge. Very well. So let me introduce you to Opa. So Alejandro is one of our very beloved partners from QNow. He is a data architect, a chemistician, a quantum researcher, founder at QNow, and he has built a knowledge graph AI that converts unstructured data into decisions, then extended into quantum applied research in life sciences and financial services. He has an extensive experience in the pharmaceutical and software industries, has published different papers. He is a breath of knowledge, and I'm so happy to have him here, being able to share with you all of the work that they have done. So, with that, Alejandro, if you could try to share your screen.
Me dice que no tengo
Que no
permiso.
puedes. Voy. Excuse me.
Tranqui.
Ok, inténtalo de nuevo, por favor. ¿Vas a presentar en inglés o español?
Español.
Espérate, un toque. Voy. Entonces yo tengo que ser interpretadora para inglés. Okay, so for everyone who is in English, if you have not set up your interpretation language to English and your closed captioning language to English, you must do that now. Alejandra is going to be presenting in Spanish, and yours truly is going to do her best to present to you in English. Um, what we could do is, if it's not that great, I'm going to make a video after this with a more timely presentation where I get the terms right. So remember, this is best effort. So what I'm going to do is I'm going to set myself as an interpreter, and then you will not be able to hear me for a little bit. And so you need to use the chat, and our other organizers are going to be able to support you. Okay. Again, if you did not set it up, it's on the Discord channel how to do it. Ask for help, but I'm going to set myself as an interpreter now.
Bueno.
Oh, one moment. Yo te hago así para que empieces, ¿ok?
Buenas tardes. ¿Se escucha bien?
Sí se escucha bien, y espérate un momento, voy para inglés.
Perfecto.
Okay, can you confirm that you hear me in English through the chat, please?
Yo no te escucho. Alice. Listo. Perfecto. Entonces decime cuándo arranco, Dani. Bueno, buenas tardes, buenos días y buenas noches. Ahora
Good evening, good night, and hold on.
bueno,
Tell him to go slowly.
Pues a la empresa un poco, ¿cierto? Somos una compañía que se encarga de la generación, la minería del conocimiento, ¿sí? Transformando datos no estructurados en básicamente decisiones que van a ser
Now is a
tomadas.
company that is
El equipo básicamente se
hold
conforma
on.
de nosotros, ¿sí? Por mi lado, soy químico, como ya me
Now is a
presentaron.
company
Mariano,
that
que
is under the
nos gusta el
following
lado de la física.
group.
Daniel, que
Is Alejandro Mariano Caruso, who is focused on physics.
está también allá en la
Danielle,
fortuna, y Nico de la infraestructura. Ese es el equipo presentado rápidamente, y el propósito
who
de
is
esta
in charge of
charla
our
es
infrastructure.
hablar
And that is our
concretamente de
team
cómo
rapidly
podemos utilizar
presented.
lo que
The
existe en
purpose
este momento
of our
en temas de
talk
Machine Learning,
is to talk
¿sí?
rapidly
Aplicado a casos concretos de
about
uso en el
how
área de
this
Life
momentum
Science,
of
¿sí?
machine
En este
learning
caso se titula
is
Quantum
applied
Multiple
to
Kernel Learning
concrete
Approach for Drug Discovery,
use cases.
¿sí? El DOI, si en algún momento
So we are
quisieran
talking about
pasar por
quantum
ahí y echar
multi-learning
un poquito
for drug
feedback,
discovery
es
approach.
este. Y
If you want to check out our paper and give us some feedback, please do. That is the link in archive.
investigadores que
He's
los otros investigadores únicamente me
he
la podían abrir en silla
is connecting
y
for
me
the
llamo
for me.
Benjamin
So
Oniceto.
these are the
La pequeña
researchers
agenda
that
del
we
día de hoy es
have,
como
and they
tratar de
count
aterrizar
with the
esta visión, quizás que está un
support
poco lejos de
of
qué hacer con Quantum
various
Computing, en
organizations.
palabras muy
The
parecidas
agenda
a lo que
today
estábamos viendo hace un
is to be
instante
able to
del otro
lend this
speaker
vision
que mencionaba que era un pipeline de datos, todas
in
estas,
use cases, and
todos
want to
estos
make
pasos que son
sure
necesarios
that
antes de
we bring
entrenar
together a
un
lot of
modelo,
the terms
¿cierto?
in the previous
Entonces, por
video.
eso, gran
By
parte de lo que
bringing
vamos a ver hoy
all of the
es ver
different
todo
steps
el
that are
ecosistema, todo
necessary to bring a model to a successful completion. So here we want to look at
con
another data
una serie de
pipeline
pasos de
and the whole
probabilidad
entire
química,
system
¿sí?
that
Y
we're
el
bringing
contexto del
together.
life science. También la idea es
By
ver
thinking about the steps
cómo
that we
nosotros
can
podemos
bring
aprovechar
forward for
esos,
chemistry.
esos ajustes que podemos hacer con quantum computing en una metodología muy específica para la
Also, how can we
predicción de la
take
actividad
advantage
molecular
of the
del sistema,
adjustments that
¿cierto?
we use for quantum
Bueno,
computing
para empezar,
so we
empecemos del
can
contexto.
observe and analyze the molecular activity? To get started, let's look into some
El
context.
desarrollo de medicamentos es una mayoría de compuestos que se investigan, ¿sí? Nunca salen a producción. Es decir, existe una tasa de
The
productos
majority of
multipletos
the compounds that are
que
investigated
son
don't
en
go out into
relación a los que se
production.
investigan muy
We
pocos,
have a lot of
¿sí?
medicine
Y esto tiene mucho sentido,
that
porque los
are
medicamentos tienen que
related
pasar por
to
ciertos
research that
trámites y
are
ciertas,
not non-public because
digámoslo, garantías
pharmaceutical drugs need to go through a lot of trials and guarantees.
de que el medicamento es consumible, ¿no? Lo podemos ver en términos, si lo vemos en términos míos, sí, dependiendo del
Make
medicamento.
sure that it is
Y
safe and
existe de alguna
consumable.
manera una especie de etapas en las que las podemos ver, que sería desde la identificación de la enfermedad, ¿cierto?
There are a couple of
¿Qué estamos
stages that we
buscando
can observe
nosotros?
from the
Contar o resolver
identification
nuestra
of
diana,
the
¿sí?
disease
Una etapa donde estamos haciendo una
so we
especie de
can
descubrimiento de esos
understand what is
compuestos
occurring
que
with
van a tener ese
individuals.
margen terapéutico o con la esperanza de que lo
And we
tengan,
look at this
¿cierto?
discovery of compounds where we consider potential therapeutic uses of the compounds.
Y en última instancia, después de encontrar esos componentes, tengan sistemas parecidos a los que tenemos nosotros como seres humanos, ¿cierto? Con el propósito de pasar por una serie
And
de
after
experimentos en
finding
personas
those
enfermas,
components, there are
¿cierto? Con
some
esta
systems
condición
that are
y probar estos
similar
pequeños
to that,
fragmentos.
and then we go through
Entonces,
multiple
todo esto pasa
experiments
antes
where
de
we
que se le
can
entrega a
improve
entidades
some of
como
these
la
conditions.
FDA y la EMA, que son los que regulan los medicamentos y los
This
alimentos
is
pues, que salen al
the
mercado.
process that
Entonces,
is
de
followed
todo ese
before we
experimento
go into the
se
FDA
aprueba
and
un
the
solo
EMA.
compuesto de
So
muchos compuestos
this
que se
entire
buscan, por eso la
experiment
expresión era pocos
for
menos
just
luz,
one single
¿sí?
compound
Y este
out of
pipeline no solo
so
es
many
costoso, sino que lleva mucho
is what goes through this pipeline. It is very costly.
tiempo de desarrollo, que implica que pueden, ¿cierto? Pero eso es una forma de verlo un poco irresponsable. Vamos a pensar de la siguiente manera. Esta imagen que estamos viendo acá, ¿cierto? Si la
Let's
vemos, aparte
represent
de
it
lo
the following way.
estéticamente bien que se ve, si vemos cada punto, ¿sí? Y lo pensamos como un
The
compuesto químico,
about the aesthetic,
vamos a
and we look at
entender
each
que la
point
búsqueda de compuestos
as a
químicos en este
chemical
espacio que
compound.
estamos viendo acá
We're
no es
going
sencillo.
to understand
¿Qué acontece?
that the
Que el
search of
espacio de moléculas que
compound
pueden resultar
chemistry
ser
is
útiles
not simple.
para
The
determinada
space of
fase
the
es un espacio
chemicals
de
or
búsqueda
molecules that can be useful to determine a target is a space
de 10 a la 60 aproximadamente.
for the
¿Sí?
realm of all
De
possible
espacios
molecules
que
is
nos van a
vast.
necesitar buscar un compuesto que sea útil y competente, ¿cierto? Para el target que estás
These are
buscando.
the spaces where
Esa
you're
tarea
going
no
to
es
be looking
sencilla,
for a
¿sí?
compound
Como podrán
that
imaginar, es
is
una
a
tarea que es
target that
costosa,
you are looking for.
computacionalmente hablando, ¿cierto? ¿Qué
As you can
acontece?
imagine, this is very
Que es
costly,
importante encontrar
both
métodos
time
que faciliten hacer esa
and
especie de funnel,
financially.
¿cierto?
So what happened? It is very important to find methods that can create a funnel for cost saving.
De filtro para llegar tenga ese margen terapéutico. Este screening no está, este filtrado es parte
So
de
we
un
can look
flujo de
at
datos,
this as a
¿sí?
process of
Sobre eso
filtering
justamente a
compounds and
aplicar.
molecules until we
Entonces de aquí
can
vamos a
find
hablar
one that
justamente
has a
qué es el
therapeutic
QSAR,
use.
qué es el método concretamente, ¿sí? El método de QSAR es un método que
So
viene
Qs
de
are
la
the method that
química
we
informática,
developed.
¿sí? Básicamente lo que estamos buscando nosotros
This
es,
comes from
dado unos experimentos que se hicieron,
bioinformatics,
¿sí?
biochemistry
Y
information.
un set de moléculas que se probaron, ¿cierto? Para validar de que esas moléculas podrían curar una enfermedad. Yo quiero
So this is about looking at different molecules and
crear un mundo
compounds that
práctico,
are
¿cierto?
being able
Si en un
to
compuesto
or validate
esta data que yo
a
tengo acá,
change
¿cierto?
in a
Parecida a ese
disease.
compuesto va a tener actividad biológica o no, ¿cierto? Esto porque es útil,
So the data that
porque
is here is
en el
going to
caso
have
de lo que estamos
biological
buscando ahora, hablando de
activity.
medicamentos, estamos buscando encontrar si estos compuestos que yo quiero predecir, que estos son desconocidos, van a tener o no margen terapéutico.
We're looking for medicines. We are looking for
Como dicen
molecules and
Giraldo,
compounds
¿sí?
that are going to
Entonces
have a
tengo rango de
therapeutic
error,
margin.
¿sí? Bueno, ahora, ¿por qué QSAR? ¿Por qué estamos hablando de QSAR en el
This is
desarrollo de
like a needle
medicamentos?
in a
Bueno,
haystack.
esta metodología es de cómputo
So why are we talking
clásico,
about QSR in
¿cierto?
the development
Tradicionalmente se
of
han trabajado
drugs?
modelos de machine learning en ella y
Because the
la
classical
idea de esta
methods
conversación es hablarlo como
where we
nuestro
use
Python
machine
generativo max,
learning
¿cierto? Para desambiguar
is
un
what is
poco
being
y
used.
exponer
I would like
quizás
to
el temor que
invite you
existen con las
to consider
tecnologías
this as another
como
data
pues estamos
pipeline.
hablando en este Full Fest, ¿cierto? Inicialmente todo parte de que tenemos la data,
And we're looking for all the technologies that we're talking about during this fall fest. Initially, we have all these data
de
and we're
la,
looking into
¿cierto?
which
¿Quieres
classical
la malaria? Sí,
models
tenemos
we're
una enfermedad en
going to
concreto
use so we
que queremos
can
estudiar y tenemos las
associate it to
proteínas
the
concretas que
target.
nos interesan a nosotros. Esa
We
data que
have
se
a
recolecta en
concrete
el laboratorio, ¿cierto?
disease and we have a
Se pasa
concrete
por el módulo o el proceso que
system
estábamos viendo atrás, que es un proceso de machine learning básicamente,
to
y
evaluate.
básicamente se hace ese filtrado,
Go
¿cierto?
through
QSAR nos
this
va a
with a
servir para
machine learning
filtrar esas
process.
moléculas que son activas, que
And you
son
do this
relevantes,
filtering
para que se sinteticen esos
so you can
compuestos.
understand which
Porque si
molecules
hacemos el esfuerzo
are
de
active
sintetizar
so you can
el espacio de
synthesize
10 a la
those
60,
compounds.
probablemente no vamos a ser capaces de lograrlo en esta vía de
Because if you
investigación.
were to synthesize the space of 10 to the 60th power, then you would not be able to and do this in this
Tiempo,
lifetime.
¿cierto? Por eso es que es tan importante encontrar ese club, ¿sí? En el que encontramos justamente esos candidatos estrella. Ahora, esa es la recolección de los
That
datos,
is why it is
¿cierto?
so important to
Normalmente la
find
recolección de los datos viene de fuentes
the
de
sub
desarrollo
data
pues
sets of
especializadas en
that are
Python, por
candidates
ejemplo,
where we can
que
synthesize the
facilitan data para
prioritized
investigación.
compounds.
Está disponible ahí para que se use. Y básicamente se requiere también
So
entendimiento
there's a
de
lot of data that is available for you to
desarrollo.
use. You also need to understand
Estás
proteins
tratando,
that you are
¿cierto?
targeting.
Eso va a ser, pues, por ejemplo, analizando el desempeño de tu modelo, ¿cierto? A personas del área médica, ¿sí? Bueno,
That
en
is how
esencia,
you
para
are
entender
going
lo
to
que estamos
analyze
compartiendo
the
hoy,
performance of your
hablamos
model.
justamente de este inhibidor, ¿cierto?
In
Nosotros
essence, for the
vulgarmente le
article
decimos
that we're
DILT,
sharing
¿sí? Por la
today,
forma en la
we're
que
looking at this
alfanuméricamente se ve el nombre.
inhibitor.
Pero básicamente es un target muy interesante en enfermedades o desórdenes neurodegenerativos, ¿cierto? Por ejemplo,
Basically,
en el
this
Alzheimer
is a target that is very
y
interesting
demás, y se
in
usa simplemente como
neurodegenerative
pues parte del estudio que
disorders.
estamos haciendo.
And we use it as part of the research that we are doing
Porque
because
el foco es Machine Learning, ¿cierto? No es y un modelo cuántico y compararlos, ¿cierto? En target. Ahora, todos los proyectos son datos
because the
que
focus
representas de una
here
manera,
is machine
dependiendo de
learning,
cómo lo representes, pues puedes
all the methods
aprovecharlo,
of
¿sí?
machine learning
Y lo que quiero
that we
traerles
are
aquí
representing. You need to ensure that the way that we are presenting
básicamente
this is in a way that is usable.
como nosotros lo hacemos. Nosotros
Sorry,
usamos
we're having some
molecular
connection
descriptors,
issues with the
descriptors
internet.
representar los atributos de las moléculas, ¿sí? Entonces, básicamente los SMILES,
So the
para empezar
molecular
con los SMILES,
descriptors
es
are
la
the
representación
attributes of the molecule
en
that we are
formato string,
looking
¿cierto?
are
Que
what we're
tienen las moléculas.
using. So let's start by this
En este caso, la
files, the
pirina sería
simplified
azul.
molecular input
Este es el
line entry
numeritos químicos,
system.
¿cierto? Pero el formato en representación string es este que estamos viendo acá
This
abajo,
is the chemistry
C1, C2.
representation of the pyridine.
Nosotros eso lo vamos a utilizar en
And
programas
these
de
are the
cómputo
sequences
como
that we're
RDKit,
observing.
¿cierto? Para hacer cálculos sobre ese
This
string. Es
is
decir,
what
ese
we
string
use
es una
in the
identificación
computational
que nos
program
va
that
a
is
nosotros
called
a permitir hacer
RDKit.
cálculos sobre esa molécula. Es más o menos como se ve el CSV
And
cuando lo estamos viendo en
it will
formato tabular.
enable an identification that will allow us to calculations on that molecule,
Sí,
allowing us to identify activity or the further analysis of susceptibility
el
in
elemento, en este
patients.
caso oxígeno, por ejemplo, unos features en los cuales nosotros, ¿cierto? Y estos van a ser nuestros presentan una actividad ¿cierto? Sobre el target que estamos hablando nosotros, que es el
These are going
público,
to be our
¿sí?
candidates.
Listo. Con esa
The
imagen mental
activity over the
muy
target that
tradicional,
you're talking
¿qué
about.
podemos hacer nosotros? Bueno, yo puedo
With this
describir un auto
image
en
of
términos de
traditional
sus
data, what
colores,
can
de
we
las
do?
llantas, del motor, ¿cierto? Es decir, yo puedo volver
I
toda
can
esa descripción
describe a
un vector,
car
¿no?
in terms of its colors, its brand, everything that is within its brand
Entonces, me
or
interesa
definition.
tomar un dataset y vamos a describirlo en términos de sus descriptores. Esto es una lista no
So
exhaustiva de algunos de los descriptores
it's
con los que están
very important
descritos en
to take this
pues, en el
data
artículo.
set
Y por
and
ejemplo, son
describe it in a
características,
list of
así
its
como
descriptors.
le
It is
atribuimos al
definitely a
carro un motor,
non-descriptive
le podemos,
list,
por ejemplo, atribuir a un compuesto la cantidad de
but they are
enlaces que le permite
characteristics
rotar a la molécula,
similar to
¿sí?
how we
O por
attribute
ejemplo,
a
esto
type
es
of
un índice para
motor
expresar
to a
la
car.
conectividad que
We
tiene,
can
por
attribute
ejemplo,
certain
un molécula en
characteristics
términos
to
de
these
sus
molecules
vecinos, como si lo viéramos
that
como
will
un
help
grafo.
us express the
Y
connectivity that
así también podemos
it
expresar la
has with
molécula en
its
términos
neighbors at a certain degree. And to that level, we can express how a molecule is interacting.
peso molecular, ¿cierto? Pero a nivel de estudio de química computacional y clínico para yo decir, esa molécula cuenta con estos atributos, ¿cierto? O va a
And
ser
their
buen
atomic
medicamento porque
weight,
tiene ciertos atributos a nivel de
because these are
descriptores que me dice que va a ser buen
key
medicamento,
attributes
¿sí?
for it
Por
to
eso es tan
be
interesante y tan
good
valioso hablar de los
drugs.
descriptores como los
These
features.
attributes are critical
Ahora,
for
al ser
them to
data,
be,
¿cierto? Al ser simplemente un CSV con muchas
no, eh, this is just data, like an Excel
columnas,
spreadsheet, a
eso me pido
CSV
supeditado a que
with
pase por una procesura de
multidimensionals.
datos, como la reducción de dimensionalidad, ¿sí?
So we
Las
know
capas
that
de machine
there's
learning
going to be a
cuántico que se
need
van
of
a encontrar
preprocessing
en un
and
futuro
a
muy lejano,
dimensionality
es
reduction.
interesante, por ejemplo, hacer una reducción de dimensionalidad
The reason
porque
that we bring
necesitas
this
es
up
que
is
la
because
relación,
we're
en este
gonna
caso,
run into this
de los
in
qubits que
the
vas a
not
usar,
very far
sea
future,
proporcional a la cantidad de
where
componentes que haces en la reducción de la
dimensionality
dimensionalidad, ¿cierto? Tú
reduction
puedes trabajar con
is
N
key for you to use the number of qubits
features
that
porque
you're
te
going to
vas a
have
quedar
in
sin
your
qubits muy
data.
rápido, ¿sí?
You can work
Entonces,
with
si bien la reducción de dimensionalidad
n
permite
type
que
of data
usemos
because you will run out of
información,
qubits
¿cierto?
to where
Que
the
está
technology
en,
is today. It's critical for you to do dimensionality reduction. So the information that is here is for you to start
incrementos
seeing how
se
you
mantenga,
can map this
es un
data
parámetro flexible, ¿sí? El día de hoy y el día de mañana.
by
Bueno,
maintaining
en
the
esencia,
key
el
features
procesamiento de
in
todos estos
a
datos llega
parameter
a
that
una
you will
partecita que
need
estamos viendo aquí
today and
como
tomorrow.
Quantum Maps, que es en lo que nos vamos a enfocar a continuación. Los mapeos, antes de llegar a los Quantum Maps,
Now here we're going to
van a
focus on
facilitar
the
a
next step
nosotros
of quantum marks.
traducir la data en las dimensiones en las que
Mapping this is going to enable us to translate the data
queremos un espacio dimensional, ¿cierto? Mayor. ¿Cómo así?
into a quantum
Yo quiero
data.
tener mi dataset, digamos que nuestro dataset es este de puntos azules y verdes, ¿sí? Y este dataset es fácilmente separable en el sentido de
So
que
let's assume that this
están
is a
pues
data of
distanciados por una pues
blue
visible
and
distancia,
green
¿cierto? Y
dots,
puedo trazar un plano,
and we want
una
to
línea recta que me da
separate
una
them
métrica
distance that is
coherente
visible
de separación.
through
¿Qué
two
pasa
planes,
cuando
which allow me to have a coherent
los datos
model.
están muy mezclados? Entre puntos verdes y azules se me va a dificultar.
So
¿Qué
as you
se
can
suele
see,
hacer? Se suele mapear estos puntos que están en dos
these
dimensiones,
data
en n
set is
dimensiones, en
very
este caso es un ejemplo en
important.
3 dimensiones, para crear este
So
hiperplano de separación, ¿sí?
is
Uy,
that
espérame,
we map these two data
que nos
sets
va a facilitar hacer la
in bigger
clasificación de,
dimensions
por ejemplo,
so we
esto
can
es
see
una
an
transacción que es
additional layer of
fraudulenta,
separation.
o esto
You
es un
see on the
gatico
right,
rojo y esto
there
es
is
un
the
azul,
points, and the
¿cierto?
other one you can see the
Es decir,
separation of the data in the
es
two-dimensional.
agnóstico al problema, ¿cierto? Lo interesante es la estrategia de hacer ese mapeo de características
Is
con un espacio
agnostic to the
dimensionalidad
problem.
mayor.
This is a classical strategy that is agnostic of the problem that we're looking at. What we are doing is mapping the data that we have collected.
Este modelo es uno de los modelos y este que
This
tenemos
is
acá es otro
many
modelo muy
other
famoso que es
settings.
el Extreme Gradient Boost. Rápidamente y para
This
contexto
model
lo
that
usamos
we
también
have
como parte del benchmark,
is
¿cierto?
very
Para el modelo
famous,
híbrido que se entrenó.
and this
Y
is
en
what we
esencia,
use
él lo que
for
hace es que
a
estás
benchmark.
buscando
This edge
arbolitos
is
pequeños
the
de
extreme
decisión
gradient
y
boosting,
vas a
and what it
encontrar el
does,
mejor arbolito de decisión para
what it
poder hacer
starts
esa
looking
predicción. es
decision
un
trees
algoritmo muy robusto y la
until
versión que
you
estamos viendo
find
acá de ese
proper
algoritmo
decision
es
tree
el
for
mismo algoritmo en el
production.
GBoost, pero de manera federada, es decir, con una estrategia a nivel ingenieril para que sea
And what we do here is same XGBoost algorithm, but in a federated approach, ensembled approach, it
inclusive
seems.
mucho más poderoso. Bueno, eso es como para entender cuáles fueron las partes clásicas que nos sirvieron de benchmarking a nosotros, ¿sí? Ahora, sigamos
Now,
con el pipeline.
we went through that so
Ya
you can
pasamos
understand what the
nosotros
classical
por el
parts of an
procesamiento,
AI
tenemos la
machine
data a
learning
punto,
do.
sí,
Now,
pero la
going to the
data
next step, which is the
tal
pipeline,
cual no la
and
podemos
we're
meter así en
going
un computador cuántico.
to the next
Sí,
step.
necesitamos hacer diferentes mapeos
We have the key data set.
y,
So we
y a
can't
esto
just take that data, the way that we have it, and put it in a quantum computer, which is
básicamente
why
lógico
now the
para
key
poderlo hacer
point
nosotros.
of
Por eso
literature
vamos a ir de
technologies
alguna manera por
comes
estas
together.
tres secciones rápidamente y es cómo nosotros tomamos los datos y usamos esta
Now we're going to go through
representación
these three
para hacer
sections rapidly,
un mapeo
which
cuántico
is how do
usando un
we
quantum kernel
translate
transformados.
these data
Entonces,
sets
en esta
into
parte del pipeline nos
a
enfocamos en
quantum
crear
encoding feature.
lo que van a ser los hiperplanos que
Part
van
of
a
the
separar la data
pipeline,
de
we
manera
focus on
clásica,
creating
en este caso el radial base, ¿sí?
hyperplanes are that are going to separate the data
Kernels
sets and the
customizados
diagonal set.
que nos van a facilitar a nosotros
We're going to use RPF kernels, we're going to use custom kernels, and then
hacer el
quantum
mapeo de
kernels.
características de los datos clásicos y los quantum kernels pues que tenemos casi que por defecto. Estas tres cositas básicamente es el baseline. ¿Por qué es
Now we're
importante
going to
esto?
do
Voy a hacer un poco de hincapié aquí, porque
kernels
para nosotros
almost by
comparar un modelo
natural
híbrido
description.
necesitamos sí o sí su
However,
contraparte
here,
clásica. Sí, no
for
podemos
us
hablar
to
de
compare a hybrid
mejoras,
model,
de
we
utilidad, de
need
advantage, si no
a
tenemos su contraparte
classical
clásica
counterpart.
medianamente comparable, ¿cierto? Y muchos
We
ensayos.
cannot talk
Entonces,
about a
de
quantum
ahí es que
advantage if we
tengamos
don't
este
have
step
something
con
in
estas
classical that we can
consideraciones.
compare. That's why we have this step so we can see where quantum is
Ahora,
playing
esta
a
palabra que
better
básicamente creamos los
role in
que se
terms of
encargan de lo
analyzing
siguiente.
it.
Nuevamente, tenemos el mismo problema del support vector machine.
So this is where
Tenemos
we
en este caso, pues mis
create
puntos de datos están
these
aquí, en este
kernels.
contexto. Si yo quisiera atravesar una línea recta en
We
esta
have
figura que me separe la mayor cantidad
context.
de
If you were
puntos,
to
pues
cut
no lo voy
a
a lograr
straight
tan
line in
fácil,
this
¿cierto?
figure,
¿Qué
in
me
this
implica?
panel,
Que yo necesito mapearlos en un
you
espacio
wouldn't be able
diferente.
to achieve that.
Aquí estoy mostrando simplemente cómo se hace
Is
un mapeo
that you need
en
to
par de
map these
compuertas
data sets
y lo vamos a
into
mapear de forma tal que me
space.
permita expresarlo de
Now
forma
we're
que
going to
sea
put here
separable.
with different quantum gates and compute it in a way that is
¿Sí? De allí que nos
separated and
vayamos
computable.
nosotros buscando llegar. Esta acción de mapear, ¿sí? Se puede hacer de muchas
Now
formas
here
y eso es lo que
is
tiene un
how
proceso
we map
computacional interesante de analizar. Porque estamos
to
hablando de eso que
spaces that
llaman
we
el
can.
kernel trick. Porque es
This is
interesante ese
something that you
kernel
could
trick,
do
porque
in
vamos a
many
hacerlo
ways.
en esta
And
vez, en
it
esta
is what
ocasión lo
is
vamos a hacer por
interesting because it will
pedazos.
have
Es decir,
different
esta
computational
operación de
costs for you.
hacer el encoding en estas
What we're
compuertas,
going to do is
¿sí?
going to
Que
do by
después más adelante
repeat. So what we're going to do is we're going to do the encoding in these different
las van a ver súper profundo bien.
gates.
Una función, ¿sí? Una función que me va a codificar en ángulos, en términos de ángulos, desde 0 a 3pi,
Next
por
way,
ejemplo,
I'm putting my
o lo
data
que
set
sea,
to
¿cierto?
a
Estoy pasando mi
function.
función por una función que multiplica mi número por lo que sea, ¿sí? Lo que nos interesa es ese concepto. Lo estoy pasando por
I'm going
una
to put my
función.
function
Mi
to
conjunto de números, ¿sí?
multiplies
Que del 7 al
some
22, en este caso puedo paralelizarlo también, ¿sí?
the
¿Qué
numbers
significa?
I
Que yo
have
puedo dividir
between 7 and
computacionalmente a nivel de
22
programa el problema de
be
tener una gran matriz en sus matrices.
dimensional. What I'm doing is taking the big problem and making
Pequeñas, el
smaller
problema de sus matrices
subsets or
pequeñas, ¿no?
matrices so
Por eso
I
es un
can
ejemplo de
process it
procesamiento paralelo que también lo estábamos conversando ahorita con el compañero.
eventually.
Ahora,
Parallel
ese problema, sí, tiene un extra adicional, que es un problema que se llama, o más bien, una
problem
estrategia que se llama multikernel
has
alignment,
an extra
¿sí? Que va a ser una situación donde
dimension
vas a necesitar encontrar cuáles de esas combinaciones
problem.
de esos kernels que estás creando, ¿sí? Es la mejor.
When
Y
you
bueno,
find yourself,
para ver
which
eso
one
vamos
of
a
those
adentrarnos un
kernel
poquito más en qué es lo que
combinations
hace
that you
esos
are
kernels
creating,
concretamente.
best ones,
Imaginen que
how do
ustedes
you
tienen una imagen imagen de,
find
no sé,
the
esto
best one. Imagine you have an image.
vamos a suponer una ciudad o la foto de una ciudad. Hacer que nuestro programa
Similar to this
capture la mayor cantidad de
with a
información, ¿cierto? En cada
picture
uno de estos
of a
kernels,
city.
¿cierto? Que tiene, digamos, 3 aquí o
We
puede tener
want our
n
program to
realmente,
capture the majority of
con el propósito
information
de que
in
encontremos
kernels
entre la suma de esos kernels cuál es el mejor que
with
nos
the
facilita la predicción,
objective
cuál es el mejor
to
kernel que facilita
understand
esa
between
predicción,
the
¿sí?
summation of this
Idealmente lo que
kernels, which is the one that facilitates the prediction.
optimicemos de manera en n pasos o en n k y que se pueda hacer una decisión o entrenar sobre esos pesos, ¿cierto?
So
Asegurando que tengas un mejor resultado. Ese
do
proceso es
this
muy
in
parecido al
n
Divide and
steps
Conquer,
so
que
we
está
can
bastante
make
relacionado por
a
ahí o habrán escuchado.
trained
Ese problema de tener
decision.
estos
It is
acá,
very
así como se
similar
ven,
to the concept of
conlleva otro
defining
problema adicional, que es el problema del alineamiento.
it
Y
is
es,
probably
yo para resolver el
the
problema de
problem
tenerlos
in these
así,
guys in a
cuando tengo
2D
estas
phase is
matrices, se forma,
just
digamos,
an
de una
additional
forma
problem of
mental, quiero
alignment
que hagamos esto,
because
se forman estas figuras,
for us to
son
have
más
this
complejas
kind of
intuitivamente de
matrix
resolver
and a
que
mental
esto, en el
to have more, 3D map becomes, it's more complex in an intuitive
sentido
way.
de que si que están en una montaña, de repente próximo hacia el valle de la montaña, es más complejo pensar en esta ruta que pensar en
Imagine that
esta
you have
ruta,
the top and
¿sí?
the right
El,
section.
si bien
We're trying to
son
find the
quizás
minimum,
palabras un poco
and
complejas
it's
en
more
este momento,
complex to find
lo podemos ver
this
así.
route
Las funciones
than the one
convexas,
where you
o
jump right over the
imagínense
cliff.
todas las
But
que
you
son curvas, y son aquellas funciones
think
en las que
about
vas a trazar una línea y se cortan dos puntos,
functions.
¿cierto? Es en forma de U. Eso es una función convexa.
You're going
Entonces, mi problema de
to
los kernels, que se
align
ve así en
between
este
2 points.
momento, esto que tengo acá arriba, se ve así,
So
lo
one
voy
of
a
the
traducir
problems with these kernels when you're trying to find the minimum is that we need to translate it
en un programa convexo. Programas en Python que te facilitan hacer esas optimizaciones y son importantes como
into
pues,
a
para llegar
convex
a un resultado óptimo en el
state.
proceso
So
del
we can
entrenamiento
look
neuronal o en el momento en el que
at
estés combinando
optimization
esos
that
kernels.
brings through
Entonces,
an
por
optimal
ejemplo, lo que
results.
estamos viendo acá es justamente, son 7 kernels que se probaron
So for example, we're
completamente
looking here
combinándose y haciendo la
is at 7 kernels that were predicted
predicción. Básicamente se
to
hicieron
do
esto.
this SPD
Este área bajo la curva que están viendo acá era simplemente
prediction.
para ver qué tipo de alineamiento funcionaba mejor, ¿cierto? En esa técnica de vamos a alinear esas matrices, por poner un
Area here
ejemplo
to see which
aterrizado.
alignment works better.
Para finalizar, una vez tenés el kernel, o más bien, tenés la función que te va a permitir trazar ese hiperplano de separación
To wrap
del
this up, once you
modelo,
have the current
¿sí?
or the
Lo que vas a hacer
function
es, bueno,
that
vamos
is
a
going to
implementar el
help you
modelo
cross
y
that
vamos a hacer sus
diagonal
respectivas
separation,
evaluaciones,
what you're going to do
¿sí?
is
En el
to
hacer,
create the
pues,
model and create its respective evaluation. When you do it,
ustedes pueden decir acá que acá se trata, ¿cierto? En este caso un support vector machine con múltiple kernel y en el XGBoost, que estábamos viendo ahorita como parte del benchmarking,
here's a
¿sí?
support vector machine with
Tenemos estas
multiple
dos métricas
kernels,
acá, haciendo una comparación de
and
los
it's
modelos,
using
y aquí quizás se
XGBoost,
aprecia un
and
poco
the
mejor
line is part of
los
the
resultados. Bueno,
benchmarking. And you can see over
del
here in
lado
this image a
del
little
modelo
bit
de
better the
IBM, ¿cierto?
results
Utilizando
of
esta
the
técnica de
orange
alineamiento de
line.
los kernels,
So you can see
obtenemos
here
un
the
área
hybrid
bajo la
model,
curva mucho,
and you
mucho
see
mayor que lo que obtenemos de un modelo pues con el estado del arte como está,
better
sigue siendo un
area
gran modelo
or accuracy in just the baseline classical model.
de predicción, un poquito bajito en comparación. ¿Qué implican estas métricas inicialmente? Implica, para empezar, que todo
A
esto,
lower.
que estaba hablando del pipeline de descubrimiento de medicamentos, sigue siendo un pipeline de datos, ¿cierto? Fuimos desde el conocimiento de los datos, de la enfermedad, cómo lo
Do you think
representamos,
about this
cómo
pipeline
nosotros lo adecuamos para
as look at
pasárselo
the hybrid
eventualmente a un
pipeline
computador
as
cuántico,
just
¿cierto?
data
Cómo
pipeline? How do we
aprovechamos
represent it? What
las
are we
bondades
collecting?
del
How are
computador
we
cuántico
adequately
para
analyze? How do we take
calcular
advantage of the good things that quantum brings to us so we can apply it to our
similitudes,
current
esas matrices,
problems,
y cómo a
the
través de
current research
estrategias de
problems
cómputo
that we are
podemos hacer
analyzing.
que esa tarea sea eficiente. a nivel computacional. ¿Para
think
qué?
of
Para hacer un entrenamiento de un modelo. Todo eso
analyzing
apunta a que
matrices of data
básicamente
in a more efficient
en la
way.
hora, en el hoy en día, se pueden hacer
All of
cargas
this
híbridas de trabajo que puedan tener un impacto verdaderamente útil
to
en
the fact
procesos
that we can do
industriales
hybrid
actuales,
pipelines
¿cierto? O
where you
sea,
can
no está
really
lejos
have
realmente lo que podemos
an
lograr en este
impact
momento con
on
la tecnología.
current
Es
industrial
encontrar
projects.
esos
This is
espacios
not far from what
donde
we
vale la
can
pena hacer el esfuerzo a nivel de equipo.
accomplish today. What you need
Y
to do is look at what you're doing and find those spaces where it is worth the effort of looking into which quantum algorithms will be applicable for you.
básicamente
Basically,
esa es la charla. Muchas gracias. Agradecimiento a ProtoQuasar que nos facilitó. Y nada, eso. Mejor la diapositiva,
this
gracias,
is
pero ya. Muchas gracias.
my presentation. And thank you so much for allowing us to present this. Thank you. Thank you very much. Oh, I cannot speak. So what I'm going to do is if you have questions, I need you to please add them in the chat and we can ask Alejandro. Okay, so he pausado toda traducción. I have paused all translation and interpretation because as the host, I cannot pause mine without pausing everyone's. Así que, if you have any questions, si tienes alguna pregunta, por favor, hacerla en el chat o hacerla en vivo. Se pueden desmutear. Yo creo que tenemos tiempo para quizás una o dos preguntas. Okay, are people putting things?
I have a question.
Okay, go for it.
Actually, like yesterday, I was doing exactly this QSR mapping for a hackathon. And as I was going through, apparently it's not giving that much of like quite like impact and like benefits to towards the classifiers and quantum kernels. And like still I feel like the classical systems are more beneficial on this field. Or maybe that's how I got.
What kind of data set were you analyzing, Moral?
We were analyzing proteins and yeah.
Alejandro, I don't know if you have any directions or recommendations for them. You can tell them how you can increase accuracy, the way that you have done it for your project, your paper. Para subir. La pregunta rápidamente es, ella está diciendo que en su experiencia, lo que ella analizó en el mundo clásico tenía un nivel más alto de accuracy y que le estoy pidiendo a Alejandro que por favor comparta los puntos donde puede ayudar a que los modelos que ellos están
Sure,
desarrollando sean mejores.
sure, sorry.
I think he's
My internet is really slow today. Sorry for my answer, but depends on your data. If, for instance, if you have a lot of features, perhaps another model is better for you, right? It depends on the use case that you are trying to solve. So if you can share more on Discord, for sure I can ask you
Okay.
can
That that's great. I think that let's take this conversation to Discord. Please ask in the live questions channel, in the follow-up questions that you have for our speakers. We'll do our best to answer you. On Wednesday, we will be here 11 a.m. EST and I think 8:30 p.m. India, and multiple time zones, which I'm not going to try to recite because I'm going to make a mistake. So we will be sending the recordings, the notes, a reminder to join the Discord, and informing you of what we need to do. There are no assignments at this time that you need to complete except join the Discord, look into creating a GitHub account, and I will send you those things in your email. So just remember, you're only going to be able the official emails, right? Don't answer any any personal information. Keep Discord and all of that very respectful. Ask for help. We have a lot of people that want to support you in your learning journey. Entonces, para los que hablan español, vamos a estar mandando un correo